Good day and welcome back to AP European History. We're in Unit 6 talking about industrialization. We're on to Lesson 2. We've already talked about why the Industrial Revolution started in the United Kingdom. Now we're going to talk about what actually happened, what made this Industrial Revolution. So first, we need to understand that the growth of production was already beginning in England before industrialization began. That we were starting to see the growth of what historians have called the cottage industry, but you may also see it referred to as the putting out system, and sometimes you'll see it referred to as the domestic industry. Domestic because it took place in a household, in a cottage, in a family's cottage, so it's known as domestic. This went along with the agricultural revolution. So the agricultural revolution spurs this cottage industry. Because what happened is as more land was enclosed for livestock, there was demand to process the wool that came from that livestock. So here's how it worked. A merchant capitalist guy's got some money, but he needs producers. He needs people to make yarn and to make the yarn into cloth. He doesn't have a factory. He has some money, but he doesn't have enough to start a factory. So what he does is he finds a householder, a cottage, and they have a spinning wheel. And he offers them the raw wool, raw flax, later raw cotton, and says, hey, I will give you this much wool. I'll come back in a week. I will pay you money for you to spin this into this type of yarn or this type of thread. And then I'll give you more yarn if you do a good job, or I'll give you more of the raw wool and if you do a good job with it. So the family, which were usually agricultural families, they would work during the day on the farm, and then in the evenings, or if it was winter, they would work during the day when there wasn't a lot of farm work going on. And they would work, as you see in the picture in the bottom right here. You have a lady who is spinning at a spinning wheel, and you've got the gentleman of the house over there working a loom as they are doing this at home in their cottage. On average every week, the merchant would then come by, pick up the finished material, pay them, and provide more raw materials. The great thing about this is, despite the fact that it was quite inefficient, you weren't getting a whole lot of efficiency at these home-based workshops. It provided these workers with that extra income. It provided them with a little bit more money, and average English peasants were already better off. So now they have money in their pockets and they want to buy stuff, which kind of feeds right back into the Industrial Revolution. When you have money, you want to spend it on something. So something needs to be produced in order for you to buy it. So that's going to kind of build upon itself. And we're starting to see these cottagers doing okay for themselves as long as the man weaver didn't spend all the money at the local pub, which happened with too often frequency. So what was it life as these cottagers? So these cottagers, as I said, this wasn't their full-time job. It was usually a part-time gig that they're doing after their work on their farm. It was done usually in the one room of their cottage. So maybe half the room was this little workshop. There was also a cooking area, and it might be also their sleeping area. All members of the family did some kind of work. This is another picture showing the three basic types of things you would do in this, but children would probably be a part of this as well. So in the right, you see the man operating the loom. So the man does the weaving. A woman does the spinning. However, you can see the spinner is only producing a small amount of yarn for all of that you need on the loom. So usually the way it worked is you needed 4 to 5 spinners to provide enough yarn to operate the loom, which means you couldn't do that in one household. So multiple households are probably have spinners spinning, and you can see the spinning wheel is very simple. Most people could afford one of those. Not all of them could afford the loom. So you have a lot of individual homes spinning, and probably 1 out of 5 might actually have a loom in it, weaving it into cloth. Widows or unmarried women could oftentimes be hired out to do extra spinning, which is where the term spinster came from, the idea of a single woman who was not married, because they were known to be hired out as spinners, and they could pay some money so they could survive as a single woman. As demand picked up for more and more cloth, this inefficient pay could not keep up. So people immediately started looking, how can we make this better? Innovation was necessary to keep up with demand. The prices were going up, people wanted to make their profit. So Well, these are the processes they're looking at. They're looking at the carding and the combing, which is in the top left. The carding and the combing is you're taking the raw cotton or wool, which is kind of just a big bundle of fibers, and you're combing through them to straighten them out so that they're ready to go to the spinning wheel, which is on the top right, where they can be spun into thread or yarn. And then once you have enough spindles of that, you put a bunch of spindles on the loom, and that's where you will create cloth. All right, so how can they make those better? Well, first thing that happens is the invention in 1733 of the flying shuttle. So what the flying shuttle does is it makes that loom even better. So most looms, when you added this flying shuttle, could do twice as much fabric, which means you need twice as much thread. So where are you going to get all that thread? There's only so many spinsters out there spinning thread for these looms. That's where James Hargreaves come in 1765. And James invents the spinning jenny. The spinning jenny is the contraption you see here on the bottom right. It allows, still hand-powered, you can see it's a hand-powered crank on the top right of the picture, hand-powered crank, but now you can spin multiple spools of thread instead of one or maybe two, 6 to 24 spools of thread at the same time. So in someone's home, you can see this costs a little bit more, so it's going to take some investment, but you can increase your productivity by up to 24 times. It only really worked with cotton cloth, so this is going to, kind of feed into the development of the cotton revolution starting in the late 1700s, going into the 1800s. People are going to need cotton to make this type of cloth. Now you have more thread, and you need people to actually put it into cloth. So this is where the factory comes in. That now you're developing bigger and better machines. And Richard Arkwright took this idea of the spinning jenny and said, well, what if instead of doing 6 to 24 spools of thread, what if you do hundreds of spools of thread at the same time? We got to get rid of the human. We got to take the human out of the equation and power it by water. So he invents this small example of water frame at the bottom left, a machine powered by water, turning gears that then turns all the equipment on the machine. You do need a human to keep resetting it, to repair it, to keep pulling spools off, to putting thread in, all of that. But now one person, instead of doing one spool of thread, can do hundreds of spools of thread. He puts all of that into one building. He invents a mechanical carder. He brings in a bunch of looms. And by putting all of this into one building with not one or two or three or four people, but hundreds of people, then you ultimately get a factory. All of these productions, so going from the raw cotton to a finished piece of cloth, taking place in one building and in large amounts. All right, so now we have the factory system. The Industrial Revolution isn't over yet. This is the beginning of it. This is the beginning of industrialization. So you're now using water power. Weavers are doing really well because there's so much thread, and they're still doing you're doing hand-powered looms. People do try, like Edmund Cartwright invented a power loom, a mechanical weaver in 1795, but it didn't work very well, not until about the 1820s. When the power looms come on, then you really see an explosion in textiles. You see the building of textile mills all across the United States, for example. Perhaps you've been to the mill you're seeing at the bottom of your screen, the Roswell Mill. The dam is on the left. If you haven't been there, you should go there. It's a great place to visit. The dam was there to divert the water through the water mill so that it could turn all the gears, and you can see some of the ruined gears on the right there. And that would, and all of those, the water power would power the machinery. The flip side of this is a lot of workers didn't want to leave the cottage. Working in the evenings, that was something they controlled, how long they worked, how many hours they put in. They could be with their family, their kids. And these big factories weren't some of these. So where were we going to get your employees? The first workers, do you remember those foundling hospitals where thousands of orphans were turned over to these giant hospitals and they died? Well, those hospitals were very expensive. So the hospitals started hiring out the orphans as young as 5 and 6 to work in the mills for 13 to 14-hour days. So these foundlings were employed as essentially prison labor. They were put up into large dormitories, worked there 13, 14 hours a day, 6 days a week, got Sundays off, and and that paid for their upkeep. Um, as time goes on, we'll talk about how those workers get replaced because there's only so many orphans in the world, as they get replaced with other types of workers. All right, so what's the next leap forward? If you look at the bottom right, you can recognize a steam engine. Moving from water power to steam power. You may remember this from the simulation we did in class, where you put the original factories you built next to the water, next to the river, and then once steam power comes in, then you're allowed to build those factories wherever you want to, because you're powering things by burning coal and creating steam. And the steam powers the engine, because steam, as you know, builds up that pressure, and the pressure is put into the engine, which starts turning the gears, and then it's released. Goes back and forth, creating the power. Well, steam, how it got started, was actually looking for coal. England is a small island, and they'd been cutting down trees there for hundreds of years. They've been building ships out of them. Their great navy was made out of wood. They've been cutting down ships. They've been using it for firewood. They've been using it for building. They were running out of lumber. It's one of the reasons that the colonies, when they started, were sending over so much wood to England, is so they could build stuff. Well, they had coal, and coal at first was easy to extract. Some coal seams were right on the surface. You could literally go in your backyard, chip it out, take it out, and put it in your fireplace. But now all the easy coal's gone, so they got to dig deeper. Well, England has a high water table, so those mines quickly filled up with water. So what are you going to do about that? So they had to pump it out. They used horse-powered pumps to extract the water, and which is kind of where they get this idea of using horsepower as a measure of power. So the horses would go in circles and pump out the water. It was not terribly efficient. That's when Thomas Newcomen it started working with steam engines to make a pump powered by a steam engine. It didn't work great, but they started replacing the horses with these steam engines, burning a little bit of coal to pump out the water. And in 1763, it was James Watt, however, who changed everything. Because he was an engineer, Scottish engineer, working for a university. He tore apart one of these machines to put it back together, and he realized there were a bunch of inefficiencies built into it. So that's when he added things like a condenser unit by 1769, making it much more efficient. And then he got together with entrepreneurs to spread the Watt engine all over England. And it took off like a rocket, because then once they realized you could use these steam engines for pumping out water, you could also use them for a bunch of other things. So ultimately, these steam-powered machines will pump out coal mines, they'll help brew beer, they will operate all kinds of mills, from grain mills to textile mills, they'll power railroads and steamboats, and everything from transportation to agricultural production. All of those things are added to by the power of the steam engine. It also led to new advances in iron manufacturing and ultimately steel manufacturing. If you just look at iron manufacturing in the UK, you can see the impact of this Industrial Revolution. So in 1740, this chart at the bottom, 17,000 tons of iron produced in the UK. That's substantial. People had been making iron for thousands of years. The English had also been making iron. By 1788, they're up to 68,000 tons. 1796, they double that to 125,000 tons. They double it again by 1806. In only 20 years, they double that again. By 1844, they were producing 3 million tons of iron, which was more than the rest of the world combined. This is the revolution here, is making a world built out of iron based upon steam power. So what started in these textile mills and started in these coal mines is going to revolutionize almost every aspect of human endeavors. Steamboats, for example. Now, steamboats will be slow to catch on. They started experimenting with them in the 1700s. In 1807, you may remember, the first commercial steamboat began operating on the Hudson River was the Robert Fulton boat as a ferry. Was very successful in America. Steamboats actually did better in America. Because of the bulk of all the coal you needed on your ship, coal only slowly replaces the free wind power of ocean-going vessels. You can even see on Robert Fulton's steamboat here, it still had sails on it. Because if the wind was blowing in your right direction, there's no reason to burn coal. You can save that money. Wind power is free. So Wind power will continue throughout the 1800s, and really won't be until about 1860, 1870 you really start seeing that, by and large, sail power is going away and coal power is really catching on. And then eventually coal will be quickly surpassed by oil power in ships. Railroads, however, will be much quicker to catch on and much, much more profitable to catch on because wind can't blow a wagon. In 1825, George Stephenson demonstrated the first effective steam locomotive. People have been trying for a few years to put a steam engine on a wagon, a wooden wagon. Wooden wagon won't support the weight of a steam engine. Plus, you have the weight of all the coal. So they made an iron wagon. Problem with an iron wagon plus the weight of the steam engine, you can't use a typical road. So that's where they realized they're going to have to put it on iron rails, the railroad. And that's when, 1830, the locomotive, the Rocket, traveled from Liverpool to Manchester at the speedy 16 miles per hour. But it was immensely profitable. So the Rocket demonstrated in 1830 that railroads not only could work, but you could make money off of them. And it is an immense and almost immediate boon. In 20 years, railroads connect every major city in the United Kingdom. And from there, it spread across Europe. And by 1850, the speed was up. They were more efficient. They were more powerful. They could reach up to 50 miles per hour. So what did railroads do? One, they reduced shipping prices. Shipping prices go way down. It used to be relatively expensive to ship things, especially in country. If you're moving something overland, that's the most expensive way to move stuff. But now, you have a cheap way of moving things overland. You can move them from overland to a railroad head, and take those down to the sea and ship them around the world. So, trade and markets became much more national, international. So, a farmer in Northumberland, his product might now be sold internationally because it's now commercially viable to ship it on a railroad. It's affordable to ship it on a railroad. New demand for unskilled workers. As these railroads have to be built, as the locomotives have to be built, all of these things and operated, workers are needed for this. You may remember even our simulation when we built the railroads in your little town, you had to add housing for the workers. It will lead to the growth of urban areas. Urban areas where previously there had never been an urban area. Some parts of England go from a small town of 300 or 400, like your simulation, to a town of 200,000 within 20 years. And finally, this leads to people dreaming big technological dreams. This revolution in movement is huge. That before, moving by land, most people had only ever traveled by foot speed of a human or a horse. Now you can travel 50 miles per hour. And if that's possible, if powering things by steam is possible, what else is possible? And it leads to just everyone questioning everything in terms of innovation. The ideas of the Enlightenment, scientific revolution are there. The scientific revolution said, hey, your ideas should be applicable, they should be useful, they should be something that changes the way people live. Just to look at a couple maps and graphs, this one shows by 1850 all of the major rail lines in Europe. You can see England, Great Britain, well railed up. You can get on a train and kind of go anywhere. France, they've got a few lines, a few little lines. Spain has those 3 tiny little rail lines connecting 2 cities, but they don't even have a rail network. Italy doesn't have a rail network. Most of France. Germany's catching up, and we're going to talk more about how Germany catches up. They catch up very quickly and become a huge challenge to England, as will other places like Belgium and France. Zooming in on the UK, you can see their rail system. The lavender color shows where they're producing woolen cloth. Later that will turn into cotton cloth. You can see the new London as an industrial area, but you can see the new industrial areas like Birmingham, Manchester, Liverpool, Sheffield, places which were small towns before are now going to become some of the most important towns or cities in England. This chart is kind of shocking when you can see about 1750, all of these countries, all these European countries, and then Japan, were all kind of in the same place in terms of per capita industrialization. So England was at the top, but just barely. And then throughout the 1700s, they start increasing their lead. And then starting in the 1820s, they take off like a rocket. And this is per capita. By 1880, 1870, per capita, United Kingdom citizens are producing twice as much as the rest of these countries combined. That's remarkable. They will become the workshop of the world everywhere in the world was buying stuff that on the bottom, well, if they put those stickers on there, it would say made in the UK. Another map showing the major industrial areas and in urbanization areas, showing levels of urbanization. We talk about how generally things catch on in Western Europe, and now it's kind of Northwestern Europe because Spain has fallen behind. So Northwestern Europe, at this point, UK is leading the way, and ideas spread out from there. And industrialization will spread out from there.